Hello everyone. Today I am going to start the topic two-port network, which is the video series lecture of circuit theory. So here, in this topic two-port network, we are going to discuss about the network and how the port is connected to the network. There is two ports, that is input port and output port. The input port having the voltage V1 and current I1, which is going to enter in the network from the left side, and in the right side the output port having the voltage V2 and current I2. The network consists of the some resistor, maybe some capacitor, maybe some inductor, and maybe some diode. It can be anything, but here the two input port given to the network is known as the first port, and the second output port of the network is known as the output port, and that's why this topic name is two port network. Consists of the input port and output port and one network in between them. So now two port network, in this topic we are going to discuss about the impedance parameter, admittance parameter, ABCD, that is transmission parameter, and the hybrid parameter. So how we are going to represent the different variables like the input voltage, input current, output voltage, and output current. So we can able to represent the voltage with respect to and current value, and the V1 is equal to Z11 I1 plus Z12 I2, and V2 is equal to Z21 I1 plus Z22 I2, where Z11 and Z12, Z21 and Z22 are the impedance parameter. We can represent these values in a matrix, and Z11, that means it belongs to first port only, that's why it is known as the input impedance. Z represents the impedance value, and Z12 is the 1 to 2, actually the input to output, the transmit, actually this is known as impedance value, and Z22 is the output impedance. Similarly, Y11, when we are representing the current in terms of the voltage value, voltage of the input side and voltage of the output side. The Y11, Y12, Y21 and Y22 are the admittance parameter here. Similarly, in ABCD transmission parameter, we are going to discuss about, we are going to represent the input voltage and input current in terms of the output voltage and output current, where ABCD are the transmittance parameter. We can represent the transmittance parameter in matrix form also. And here next one is the hybrid parameter, where we are going to represent the input voltage and output current in terms of the input current and output voltage, where H11, H12, H21 and H22 are the hybrid parameters. So now Z11, how we can calculate the Z11 or the impedance parameter individually. The first Z11, when we are making the output side open, that means the current of the output side is 0, and the Z11 is equal to V1 by I1, and similarly Z12 is equal to V1 by I2 when we are making the input side open, and similarly Z21 is equal to V2 by I1 when we are making the second output side open, therefore there is no current, and Z22 is equal to V2 by I2 where the input side is open and therefore there is no current. And Z11 is known as the impedance parameter of the input port, okay, port 1, when port 2 is open. That means this is the input parameter or the impedance parameter of the input side when we are looking from the input side when the output port is open. Z12 is known as transfer impedance, because from 1 to 2 the transfer takes place. It is the ratio of the voltage of the port 1 to the current of at port 2. and when the port 1 is open, that means the current in the port 1 is equal to 0. Similarly, Z21 is the transfer impedance. It is the ratio of the voltage of the output side divided by current of the input side when the output port is open. Similarly, Z22 is known as the output impedance because it signifies that 22 is the second port when port 1 is open. Similarly, we'll discuss about the admittance parameter. Admittance parameter having the four parameters, the Y11, Y12, Y21 and Y22. So Y11 is the input parameter. That's why Y11 is the admittance seen looking into the port 1 when port 2 is shorted. Y12 is the transfer admittance. It is the ratio of the current in port 1 to the voltage at port 2 when port 1 is shorted. What do you mean by port 1 is shorted? That means the voltage is 0 in the port 1. If it is shorted, there is no voltage drop and voltage is 0. And when we are calculating Y21 means the 2 to 1, that is the transfer impedance from second side to port 2 to port 1, and it is the ratio of the current at the port 2 to the voltage at port 1 when the port 2 is shorted. Similarly, Y22 is the admittance seen in looking into the port 2 and when port 1 is shorted. So we have to discuss about the impedance parameter as well as the admittance parameter. Both are what? Reciprocal of each other. So when we have the matrix admittance parameter and impedance parameter, when we are calculating the inverse of the admittance parameter, we can able to calculate the impedance also by calculating the inverse of admittance parameter. So you can see we can able to represent the impedance parameter in the matrix form where the V1 and V2, the input voltage and output voltage, we can represent in terms of the input current and output current with the Z11, Z12, Z21 and Z22, where I can able to multiply these two matrix and we can able to write down the V1 with the Z11 I1 plus Z12 I2 and V2 Z21 I1 plus Z22 I2. So you can see in the scalar form we can able to compare them and write down Z11 I1 plus Z12 I2 and V2 is equal to Z21 I1 plus Z22 I2. Same thing we can do in admittance parameter where we can able to write down current in terms of voltage and current I1 can be written as Y11 I1, Y11 V1 plus Y12 V2 and similarly I2 is equal to Y21 V1 plus Y22 V2. Now come to the question. Here this is the network and here the 8 ohm resistance, 10 ohm resistance, 20 ohm resistance and 20 ohm resistance connected in the network, and this is the input port having the current I1 and the voltage V1, and the second side there is the output port having the current I2 and the voltage V2. So now how we can able to find out the impedance parameter from this circuit? For that you have to follow the method. Same thing, when you are calculating the Z11, that means you have to make the I2 0 on the right side. That means what? You can see I1 is 0. So actually when you are calculating Z11, you have to find out the equivalent resistance of this network. What? So because we are writing the V1 is equal to Z11 I1 plus Z12 I2. So when you are making the I2 0, then we can able to calculate the Z11 is equal to what? V1 by I1. So here we can able to calculate the total resistance of this circuit. Here I2 is 0, the 10 ohm and 20 ohm are in series when it is connected with the 20 ohm in parallel. So 10 plus 20 is in series 30 ohm and 30 ohm with 20 ohm in parallel. 30 into 20 because R1 into R2 by R1 plus R2 is the equivalent resistance when two resistors are connected in parallel. The 30 into 20 divided by 30 plus 20, and that combination is in series with the 8 ohm. So hence you can see the equivalent resistance of the Z11 is known as the 8 plus 20 and 30 in parallel. Similarly, when you will look from the second side Z22, when I1 is 0 we can see this part is 0, these two are in series 10 and 20, and then 30 is in parallel with the 20. We can able to calculate the equivalent resistance 20 and 30 when they are connected in parallel. That is equal to 20 into 30 by 20 plus 30, that is equal to 12 ohm. Then similarly, when we are calculating Z12, in that case I1 equal to 0, and when you are writing in the first equation I1 equal to 0, you will get V1 by I2. So here I1 part is 0, so what is the value of V1 by I2? The voltage across this 20 ohm resistor and divided by I2 is equal to the Z12. So voltage we calculated, then multiplied by what? I2, and then I got the 8 into I2 is the voltage of the input side, and when it is divided by I2, then we got 8. 8 ohm is the resistance of the Z12, and that is same as Z21 in this case. So hence we can represent all four value in matrix form, where 20, 8, 8 and 12. We will compare Z11 is equal to 20 ohm, Z12 is equal to 8 ohm, Z21 is equal to 8 ohm, Z22 is equal to 12 ohm. Now come to the admittance parameter. The same way we can able to represent the admittance parameter in terms of voltage when we are writing the expression of current. So I1 is equal to Y11 V1 plus Y12 V2, and similarly I2 is equal to what? Y21 V1 and Y22 V2, and it is written in the form of scalar form. Now come to the ABCD parameter. When we are representing the ABCD parameter, we are representing the input parameter like voltage and current of the input side in terms of the voltage and current of the output side, and where ABCD are the what? Also known as transmittance parameter or the ABCD parameter. So here V1 by V2, when I2 is 0, we can calculate by putting the value in the first equation. I2 is equal to 0, we can able to say A is equal to V1 by V2. B is equal to V1 by minus I2 when V2 is 0, and similarly I can able to calculate C is equal to I1 by V2 when I2 is 0, and D is equal to I1 by negative I2 when V2 is 0. When current is 0, that side is open, and voltage is 0, that side is short. So now we can able to represent the input voltage and the output current in terms of input current and output voltage, and that is known as the hybrid parameter. So you can see the scalar form. The V1 is equal to H11 I1 plus H12 V2, and I2 is equal to H21 I1 plus H22 V2. The hybrid parameter is commonly used in transistor modeling. So now how we can convert the impedance parameter into admittance parameter or admittance parameter into impedance parameter with the help of the matrix operation by taking the inverse. The I1 and I2 when we are representing in terms of V1 and V2, and V1 and V2 we are representing in terms of I1 and I2. So here you can see the scalar form. I1 is equal to Y11 V1 plus Y12 V2, and I2 is equal to Z11 I1 plus Z12 I2, and V2 is equal to Z21 I1 plus Z22 I2. When we are comparing here, we can see that the I is equal to Y into V and V is equal to Z into I, and we can able to write down the Y and Z are reciprocal of each other. Hence Z is equal to Y inverse, and if you calculate the inverse of the impedance parameter, then you can able to calculate the admittance parameter. So now three ways that two ports are interconnected. We can able to connect the two port in parallel, in series and in cascade. When it is connected in parallel, we can able to calculate the admittance parameter of both the circuit individually, and finally to find out the total admittance parameter of the parallel combination of the circuit, we can able to add the admittance parameter of the individual circuit. Similarly, when it is connected in series, then we can able to find out the impedance parameter of the individual circuit, and then after that we can add the impedance parameter of both the circuit to get the final impedance parameter of the series circuit, because in series impedance is added in parallel. Actually you have to find out the reciprocal of the resistance, okay, and reciprocal of the impedance to get the 1 upon equivalent impedance, and reciprocal of that is the impedance admittance. Then when it is connected in cascade, then you have to find out the ABCD parameter or transmittance parameter, and both of them you have to multiply to get the final transmittance parameter or ABCD parameter of the circuit. Thank you.